Hey, nice to meet you. Thanks for the intention, and hope everybody had the chance to get the meal. Feel free to sit down and eat it during the presentation. I have the call together with my colleague Paul, solution architect in our New York City office, and a person with a favor for ads. So just in observation of the time, we keep it rather short, so let's get started. First and foremost, I want to start with, okay, ads are a topic that's kind of different from, for example, DRM. In DRM, we see MPEG Dash as a dominant format because you need it simply to provide DRM-protected streams. For example, to Chrome, to Firefox, to any browser, and to a lot of other environments. When it comes to ads, the situation is a little bit different. So especially for ads, a lot of publishers and also broadcasters are relying on unprotected streams or relying on HLS for those unprotected streams. So talking about ads and talking just about Dash is, in that context, not really possible. So we always have to look at both formats in combination. So we start with exactly that topic. So there's an ongoing survey from us where we ask video developers worldwide for their formats that they're using and a couple of other things when it comes to codecs and to problems and so on. And I wanted to share some preliminary results out of that. So please go to this URL and help us with the survey, vote, and submit your deployments. And then we find a good overview of the state of video technology for video developers this year. So what we see is that HLS is predominant when it comes to usage, but slightly after that we see MPEG Dash. And MPEG Dash comes into place when we talk about more complex scenarios, more sophisticated scenarios, and larger organizations. If you have a website that only has short-form content with a couple of ads, okay, then you're fine with HLS. But as soon as you talk about premium content, significant ad revenues, server-side ad insertion, then you're most probably working with Dash. So interestingly enough, also CMAF is already present here in an early usage. So let's see what we see here in the next year. We're planning to do the survey on a yearly basis. When it comes to deployments, that's also very important for ads because we have different ad standards for different platforms. Flash is still out there, especially for ads that's relevant when it comes to VAST, for example. But HTML5 is the dominant platform, and we also see that OTT devices, like for example Roku or a Chromecast, are dominant and have to be considered in these conversations as well. What are your main problems? Interestingly enough, ads are underrepresented here. I mean, I think that's more because of the volume, because we have a lot of smaller companies voting here. So we will see in the final report also smaller verticals in this evaluation. I'm curious what's the problem for large organizations. But it seems that getting a player to work on all devices is the main problem out there, slightly followed by CDN issues. Anyway, having this as a baseline and also looking at the ad formats, we see that VAST is the dominant format, but we see also a pretty significant presence of server-side ad insertion. And Google IMA is definitely also part of this category, as you can do server-side ad insertion with them as well. So it's an interesting thing because server-side ad insertion is technically so much more difficult than client-side ad insertion, which we can see in the following, that so many of the developers that voted here or submitted their survey here use server-side ad insertion. Okay, handing over to Paul.
Thank you. So wanted to go back just a quick slide here. For those who aren't familiar, they're the basic ways that ads are sold in the marketplace. We have the direct sold ads, which is the traditional broadcaster model where a negotiated deal will sell a certain amount of ads for a certain piece of content. More recently, programmatic ads have developed online, particularly around the publisher market, where advertisements might not be pre-negotiated in any way. An exchange will be aware of the type of content that's being delivered, maybe have some targeting data around that, and then electronically deliver that. That can be very challenging, particularly when you're looking at something like a server-side ad model, because you don't have the kind of control over content, you don't have the awareness around it, you don't necessarily have the quality, and you can also run into content clashing issues. And then there's also holistic advertising too that comes in when you combine both of those business models together. You try to make an awareness around which deal is being sold, which deal is going to generate the most amount of revenue for the available inventory based upon that audience, based upon where they are, based upon the target information you might have around them. And these are some of the things that we can see in the intersection here that we have with the business and technology, where we create broadcasters and publishers having the different models. Some of the key differences that we see there are, for instance, in the publisher market, the use of companion ads that might need to be synchronized with a video stream, so might need to put an additional element on the web page with that video asset. Conversely, there are unique challenges that broadcasters have around the C3 and C7 windows for their ad values. The deployments of these technologies, especially as we get into the OTT market, become unique too, since so many of the devices and some of the mechanisms that have been used online to track the value of advertisements, track their placement, track their viewability, many of these metrics were really designed for the web, but they're trying now to be used in an OTT environment. And that really becomes very difficult when we look at things like the interactive ads, which we'll get to in just a moment. And then another concept that becomes a challenging aspect to deal with too is the ad decisioning, which in a broadcast environment, when you're dealing with a direct sold ad, is considerably simpler. When you get into online advertisements, you can wind up with things like geolocation considerations. You can deal with the data management platforms that have things around the demographical data that a particular viewer might be, so gender, age orientation, and so forth. Campaign targeting, so whether or not that's going to reach its fulfilled goals. And then category matching, as we talked about there. And this has really led to quite a Frankenstein market of different technologies that have tried to patchwork together and fill in those gaps. And they can wind up some very convoluted implementations. Looking at that really where we see that come into place is with the use of something around what's called the VPAID standard, which is the video player ad interface definition. That's the advertising standard that was originally meant to provide interactive functions for online advertisements. In the initial model of that was the VPAID 1.0, the Flash model. And really, even though it was used to deliver a single piece of linear video in many cases, you wound up with these very complicated Flash advertisements because they would have things in them like fraud prevention and mitigation. They would have things like, am I above the fold on the web page when the user's trying to watch that? And because those things are so valuable to a lot of the people who are distributing video, they really want to have that technology in there. Oh, and one more thing too that you sometimes get with the VPAID standard is the conditional advertisements, where they may not actually even deliver an advertisement based upon some logic that's executed in that. Up until very recently, all of those had to be delivered through Flash. But at the beginning of last year, the IAB rolled out, the Internet Advertising Bureau, rolled out the VPAID 2 standard, which allows for JavaScript in that. So we'll get into that in a little bit in a moment here. And then I think sort of continuing on the point about VPAID here, while they were intended for that interactive content, they're really not used for any of those functions. And there's better ways to enable those functions in there. The other standard, of course, is the VAST standard. And this is really the kind of more linear advertisement delivery. It's an XML result that you get for it. It's the in-market standard. And now finally, as I mentioned earlier, last year, we had the rollout of the standard 4.0. And this is the one that's really going to be the most exciting, I think, for our industry because it provides so many new functions that enable us to do things like the server-side ad stitching. So VAST 3, in-market standard, Originally designed mainly for publishers, the ad content in a VAST 3.0 ad result is typically a single progressive MP4 file. And that means that if we're trying to deliver this into an OTT environment or some other environment, we don't necessarily have the ability to adapt the quality of that for that device. It might not be compatible with the codecs that are supported in that particular environment. It means typically using another player, what's called a two-player approach, that'll have one player on top of a player that, for instance, would be rendering an adaptive stream. It also has limited viewability data, so it didn't do things like tracking really good fraud prevention and fraud mitigation, which is something that some shadier publishers would attempt to do to synthesize viewership to create additional revenue, whether it was above the fold and so forth. But it did add some things across the earlier standard that give us functions like skippable ads, companion ads, ad pods, which are kind of the traditional TV ad break where you have multiple ads together. Prior to that, it was only a single advertisement delivered at a time. So again, not the kind of advertisement that you need to support longer form creative content that's becoming more popular in the OTT environments. But now we have VAST 4, and this is really the standard that's going to be, I think, valuable to us as an industry. Included in the VAST 4 standard are multiple ready-to-serve files. So you typically see three different files in there. So you can have, for instance, a low mobile quality file, kind of a mid desktop type file, and then maybe a high HD file that could be used for OTT. It also includes a reference to a mezzanine file. So going as high as even a full-fledged ProRes file that then could be downloaded by a server-side ad management platform and transcoded and then stitched into a piece of video using, for instance, the interoperability points that we get. And that really is kind of getting us almost to that holy grail of a smooth linear playback experience without any kind of buffering, without any kind of switching. It also separates out the interactive elements for it. So I don't know about any of you, but I personally have never deliberately clicked on an interactive advertisement in my life. I've only been paid to do it. It also separates an area in the VAST ad tag to allow those tracking pieces. So traditionally or previously where the vPaid ad standard was used to code in some tracking or viewability metrics and so forth. Things like, again, that is above the fold. What definition am I using for that? For the how much that video is being viewed and so forth. These are now standardized in the IAB standard. And it also includes some new metadata. So these are things like ad categories, which can be used, for instance, to prevent brand conflicts. So you might not necessarily want to have a Nike advertisement run against a Reebok campaign or something along those lines. So the ad tag will actually include that information to prevent those conflicts. It also can be used for things like breaking news issues. If you have a programmatic ad pulled in here that's maybe going against some tragedies like a terrorist incident or something like that, a lot of brands don't want that advertisement to run next to that kind of news content. So that can be used to prevent that ad from being displayed. It also includes a conditional ad attribute. That means that there are some times when an ad platform will not want to serve an ad into a particular environment. This is something that vPaid was previously used for. It would execute some logic to determine whether or not it did or did not want to display that ad. And if it didn't, that publisher or that content provider would not have gotten that revenue from that. Now that that logic is kind of formally included in here, a publisher can identify whether or not they want to go use those ad creatives. It also includes a universal ad ID. That ad ID should, in theory anyway, be consistent across the entire advertising universe, as opposed to situations where you might have different ad IDs applying to the same ultimate ad creative with the previous standard. And it also includes some general performance improvements in the standard as well. But this lets it become very easy to go interoperate with the Dash interoperability points, which we've already talked a little bit about in some of the previous presentations. But letting us basically go from the media content into the ad content, which can either have the X-link, which then can go pull in a transcoded version, for instance, of that mezzanine file and create the appropriate output to create that then linear playback experience like so many viewers are used to for traditional linear television environments. And then resumes back into the media content has already been discussed a bit there. A variety of different ways that can be triggered into the ad. I'm sure many people here are familiar with the SCUDdy 35 markers. Essentially, that's pretty much the most common standard that we've seen in the market for that. There's also the in-band events that we can do with the dash. And HLS, of course, has a variety of options that are kind of hacked into there a bit.
Maybe in particular interesting here, it's when it comes from podcast to OTT, the translation of this SCTI-35 triggers to an OTT system that's capable of having those ad informations available for the OTT delivered ads. I think here what we see primarily is the in-band triggering using EMSG tags. That proved to be a solid system for Dash. And interestingly enough, people copy that approach from HLS, where it's de facto standard to signal ads using ID3 tags in the MPEG-2 transport stream. And people search a replacement for that system on the Dash side. And although it's not necessarily compliant with a lot of approaches in the Dash standardization or the Dash EF IOPs, that's something we see with a lot of deployments out there, I would say. Having that said, the recent trend also goes in out-of-band signaling that we will have on the next slide.
So the out-of-band signaling, when we get into things like the event stream, or the HLS playlist event, the Q-in and Q-out tags that we see. Essentially, sometimes also a sidecar file can be used here as well to go trigger, for instance, the VMAP, to go specify where in the content those particular advertisements can be leveraged. And that depends upon what the architecture that's used for those advertisements is. So we can have our server-side architecture here. Of course, we have Frankenstein, or rather is Monster, behind the ad decisioning server there. But the basic flow that we have here is essentially the end user, requests the playback of the content. That will then trigger the delivery of that Dash manifest that we're all familiar with. We'll then get to the point where we get to pulling in those X-Link events, which then can provide the ad decision server the opportunity to return the appropriate ad result, which will pull that ad content from the CDN origin. Going backwards from this a little bit, we would have the ability to have the, in a VAST4 ad tag, those pieces of content for that CDN origin pulled into this ad creative that otherwise would not have been available in a way that could be delivered through a Dash manifest and into the same codec, same profile and so forth that we're able to deliver now with a VAST4 ad tag and not have that, again, that same smooth linear playback experience. The other option is the client-side architecture. This is typically deployed in a two-player situation where you will have one player that's deliberately or exclusively for the purpose of playing back the actual content itself. And then another player that's meant for delivering the advertisement content that will, for a moment during that advertisement content, play over the actual content player. This is a little bit more popular among the publisher environments because they can get some of those more complicated tracking metrics, some of those pseudo-interactive functions and so forth in there. But of course, this is very hard to deliver into a lot of OTT environments. A Roku example is a pretty good one, could not handle the multiple player switching around quite so smoothly, as well as some smart TVs run into issues when you try to very quickly switch around those different players here. So the end user experience is not quite as good with this. Also, because you have a separate delivery mechanism here, you introduce a much easier way for a client-side ad blocker to go intercept the calls for that advertising content and then preventing the delivery to that ad player there.
What is also quite common here is talking about the SCTI-35 triggers and talking about moving linear broadcast to OTT. The triggering for client-side ads is also associated with that, obviously. So what players are doing nowadays is basically getting notifications from EMSG or e-message tags out of the Dash segments, and then based on that, calling for the client-side ad from different ad providers with ad waterfalling, etc., what we see also in the HLS world. And that's pretty much mapping what's happening on the HLS side. And here we see that the industry is relying on HLS. Google DFP, for example, is only providing HLS assets. They don't provide Dash assets, unfortunately. So here the industry has definitely to move a lot further in the future. What's also interesting here is that we see a lot of additional and different approaches. I mean, a client-side ad can be blocked, and we will talk about that in a second, by ad blockers. Similar to that, a server-side ad using a X-Link reference can be blocked as well, depending on what destination that request is going. So what are other ways of preventing ad blocking? So we have dynamic manifest manipulation as a typical approach for that. We have a demo at the end of the presentation of that, where you basically have a custom manifest that's generated only for that particular user, targeted with ads. One provider for that, which is a partner of ours, is Yospace, for example, where you not only get a tailored manifest for the particular user, you even get the redirect of the URLs through one server, because then the whole content, the content of the assets, of the media asset, as well as the ads are coming from the same URLs. So the ad blocker has no possibility in that case to actually prevent an ad block. And there are creative ways nowadays to get deeper. I mean, it's just a question of time where until ad blockers are getting more intelligent. Today, we have to have an ad reporting. Without an ad reporting, the ad is not counted towards revenue. So that are definitely the limitations for a lot of ad systems. If you can get around without an ad reporting call to your ad server, that's great. That's a beneficial situation, but those ad blocks, those reporting blocks are typically WASP compliant or any other standard compliant, and that's detected by ad blockers. The same applies to the ID free text, to the e-message text. It's just a matter of time until ad blockers getting smart enough to also pass them out of the streams. But for nowadays, for today, there are creative ways to really get rid of any ad blocker in the market, and yeah, that's a positive sign.
All right, so skipping through here. We're going to talk a little bit about Google IMA and Adobe Primetime and the dynamic ad insertion capabilities that have there, but just skipping quickly in here to some of the non-SSAI anti-ad blocking options. The most common of these is the domain obfuscation technique, where just looking at the blacklists of domains that the ad blockers operate off of, which most of them are off of one or two large lists of the sources of those ads, it will proxy the ad call to a continuously changing set of server identities, so that when we look at the what would otherwise be a well-known ad server, they'll then get a potentially randomized ad server that isn't known to any of those blacklists. And then that will usually let that ad play, but as I said, that's a very, very quickly moving cat and mouse game. So the position of both of those points are really changing on a daily basis. Then a quick show of some of the examples here. So we have So we have two examples here. This is a client-side ad insertion. What we'll see here is in about 10 seconds, the ad creative will come into the stream. And this is going to be using that second player overlay option. If I had the volume up on this, you would all be going deaf right now if the ad was, there we go. And again, one of the other issues with that too is the ad loading time can be very long. Depending upon what that ad server might have to do around the decisioning logic, who you are. And that's one of those reasons why you had those VPAID ads frequently used to proxy those actual ad creatives, because the player would think that it had an ad in there already, but the logic was still being executed on the server side. And so you had this very poor end user experience, even though you would have somebody, a content provider, a publisher, or so forth, put in a timeout in their advertisements, they would appear to have actually gotten that ad creative, even though nothing had been delivered to the end user there yet. And then the other option, or the other example that we have here, is the server-side ad insertion demo. So this is basically the ad playing back here. And then in about 10 seconds again, the ad marker in the stream will go trigger off the playback of the tracking events here. And there we go. We have the ad creative delivered. As you notice this time, there's no buffering. There's no delay for that ad. It played back smoothly. The tracking events delivered by the player to the server then will help that publisher generate revenue and ultimately become hopefully a successful business. Any questions on, we're showing here there's a very quick, we were asked to concatenate shorten down the speech a little bit. Yep.
How do you manage the scaling of your server-side solution?
Yeah, that's currently a topic for our partners. No, it's basically DNS scaling. So you have to basically reroute via a DNS entry that's providing you the scalability, and we see different partners resolving that in different ways. For example, in that case, I think, yeah, that's the demo together with VioSpace. They deliver that quite in a scalable way using traditional scalable DNS approaches. Better to ask them in detail, actually. But what we also say is such approaches work better than, for example, WebSocket-based approaches that we also saw and so on. I mean, it's really important to don't introduce a bottleneck with server-side ad insertion. Manifests that are generated on a per-user basis and also generated and personalized on a per-user basis are a scalability issue. I mean, if you have like 10 million or more concurrent users and every user requests a manifest and updates this manifest on an ongoing basis every couple of dozens of seconds, then you have to build a solution that's scalable enough to do that. I mean, there are tools out there that can do that. I mean, the GCP App Engine, for example, or AWS Lambda are things that we saw working really, really nicely for scalable manifest generation. But that's a per user operation, and that typically puts you in a lot of scalability issues. So be aware of that.
One of the common issues for AD insertion is audio, video, lip sync.
Sorry?
So, what's your
Audio, video,
Lip sync?
Honestly speaking, we haven't seen issues for audio-video lip sync variations. I mean, I think it's primarily an implementation topic, especially when it comes to the continuous usage of one player in the server-side ad insertion case, for example. I mean, you have all the information in the Dash manifest and in the ISO-based media format. You only have to do a resyncing. I mean, you have the initialization segment of the ad content that gives you a reset of the encoder of the decoder, and from there it's pretty much straightforward as we saw it. I mean, you always have content that's slightly out of the spec, especially when it comes to audio-video sync for live. That's a problem, but that can be solved on the player side. You anyway have to look at the content for a lot of metadata operations, like extracting EMSG boxes. And what we typically do is if we find a derivation, for example, from the PTS, for example, between audio and video, we correct that on the player side. But we haven't seen those issues recently anymore, yeah. Can you repeat that?
I think the challenge there is anytime you put in some metadata or some kind of data about that, there is obviously the possibility that crafty enough programmer could figure out a way to use that to block something. Of course, if you are doing a server-side delivery situation, depending upon how your server is going to be delivering that, if it's a live stream, for example, what are they going to do with that? They're just going to be able to put their own frame over it or something else over it. You'd have to figure out some sort of substitute content in that situation. So where you're doing that in a VOD environment, then that opens up the possibility for them maybe to skip ahead in that. But otherwise, I guess that's one of those things we'll have to see what the other side comes up with.
Speaking of ad blockers, what if you just block all the ad signals, the event trackers that nobody gets paid? So,
That's exactly the problem. That's exactly the problem.
What's your take on, say, codec switching between content and ads? Say if you want to go from VP9 HEVC or SDR HDR audio?
That's a good one, because we currently look a lot into VP9, especially the delivery via ISO-based media enabled a lot of VP9 deployments. Actually, I don't know if you can reset the decoder of the MSE with a new initialization segment with a new codec. I'm pretty sure that's not the case. At least it's not a common approach across different browsers. Some browsers will not handle it the same way as others. I think you have to go here again into a multiplayer scenario. The benefit of server-side ad insertion with multiple codecs versus client-side ad insertion in that case is that you have that information in advance. So you can initialize the second player already with the MSC. That's basically no problem, and can have a seamless handover between the players. And it's not ideal. It might still come together with some artifacts, but it's possible. I mean, what's the case here and what's important to consider when you have multiple codecs with different efficiencies, when you switch from a normal H.264 stream, for example, and you switch to a VP9 ad, the quality is changing. Suddenly, you can deliver a higher quality for the ad versus the normal stream. Do you want that? That's the big issue that you have to consider. And in that case, you might have to limit the available bandwidth for the ad to maintain a similar visual quality for the end user.
Of course, as you mentioned, the multiplayer approach, then you have a whole separate environment you're playing that back in. If you've had the ability to get a hold of that mezzanine file before that ad's delivered, then you've also had the opportunity to conform that to whatever encoding standard you're dealing with there, so you can avoid that problem altogether.
Movie Labs has a technical note out on the web defining how to use a DEC bundle ID for carrying either in a CID or an ALID. I'm glad you say universal identifier and ad ID in the same
In
way.
theory.
But is the VAST4 ad tag good enough, or to have equivalency with what Movie Lab has for IDER, do we need to define an ALID for ad ID?
I would say that it sounds like we're getting into another one of these situations where we have 14 standards, and somebody says we need a united standard, and now we have 15. So perpetual problem across any standardizing industry. At the end of the day, the VAST4 standard has barely had any time in the market yet, so it has yet to be seen what the real-world implications are of this, and hopefully people will not abuse that and will use it correctly.
Thanks.
Cool. Thank you.
Thank you.